Okay, hey, I just made a video on answering the first four questions, and every once in a while I get this weird error message. I don't think, for whatever reason, the program I'm using to make these videos doesn't like long videos. Probably nobody does, huh? At any rate, hey, this is question number four. So let me go over question number four, and that's why it's already up here. This was the original question, and what we were supposed to do is to solve it and express the answer in, how did I phrase it here? Oh, this is number five. Sorry, number five. Question number five. So this is question number five. And what we were supposed to do is solve the following: that express the solution set using vectors, identify a particular solution, and the solution set of the associated homogeneous system. So here was the system. I did row reduction to put it in reduced echelon form, which is here. That's assuming I didn't make any careless errors. You didn't have to do it by hand. You could have had your software calculator do it. I didn't specify in the exam, but there is row reduced form. And from there, I wrote down the associated homogeneous, right? That's where the right-hand side is 0. And solving this, what do we see? We see that Z and W are free variables. So we write down Z equals Z, W equals W. I solved for X and Y and got this. And then, because these are the free variables, these are going to be the scalar coefficients of these two vectors. How do I know what these two vectors are? Well, I need Z to be Z. There's the Z place, so I put a 1 there. And I put a 0 there because I don't want Z to impact W. And then we flip it over here for W, 1 there for W, so we get W and 0. And then look, for X, negative 1/3, that's for the Z, negative 2/3 on the W, negative 2/3. Then Y, 2/3 on the Z right there, 1/3 on the W right there. And then you have to get a particular solution because remember, probably the main theorem of the whole first chapter is that you can write the solution as the solution set of the solution set of the associated homogeneous system right here plus a particular solution. How do you get a particular solution? You can choose any one you want to choose. Your choice. You make the call. What did I do? I went back over here, and I could have just as well gone up here, right? But I made Z and W 0. How come? Because they're easy. If I make Z and W 0, I get X equals 5/3. That's where that came from. Z and W 0, I get Y equals 2/3. So what's my particular solution? Z and W 0, there's the X and the Y, put it together, there's the solution. This is a plane in 4-dimensional space. I can't draw that. The question didn't ask us to draw it. Now, I could have made Z and W anything else. 1 and 1, 1 and 2, 7 and negative 3. So, you may have different vectors written right here. This should be the same. These will be different. Okay, so that's number 5. And let me go back and do number 4. I'm going to do this in reverse order right now. I don't know why. I just did them 1 through 5. My computer dumped the answers. Let me do them the other way. I'm not going to do them all at once this time. I'll make shorter videos because I don't know if that's what's causing me to get this bizarro error message or if it's I have a virus or I don't even know what. So at any rate, I'm going to do number 4 next. So let me do number 4. And number 4 says it gives you a vector and it wants to know if it's in a given set. So sorry, when there's too much water on the board, it doesn't write properly. So number 4 asks you if 2, 1, negative 1, if this is an element of the following set. Let's see, 0, 3, negative 7, plus, and you can write it like that or you can write it like this. It was easy for me to type it horizontally. For some reason, it's easier for me to think about it vertically. So 0, 3, negative 7, it means the same thing, so it doesn't matter how you write it. 1, negative 1, 3, 1, negative 1, 3 times r, such that r is a real number. This is question number 4. What does it mean for this to be an element of this set? It would mean that we can find a value for r so that this is true. Now, if this were to be the case, we would have to have 2 equals, because there's the x-coordinate, 0 plus r, and 1 equals 3 minus r. There's the y component, the y coordinate, and then negative 1 equals negative 7 plus 3r. So if we can find an r, so all three of these are true, then the answer is yes. This is an element of that set. If we can't, then no, it's not an element of that set. I don't know why I'm doing thumbs up and thumbs down to mean yes and no, but hey, nonetheless, look at this right here. This tells me that r, the only possibility is if r is equal to 2. Put a 2 in here, 3 minus 2, 1, check. Put a 2 in here, negative 7 plus 6, negative 1, check. So the answer is yes. And that's why it's yes. I'm going to gamble here. I'm 6 minutes and 23 seconds in. Let me do question number 3 on the same video. So question number 3 is a good question, and generally speaking, is something you absolutely should know how to do, just in general in math, not just for this course, but for any course. We're given 3 points. Well, look, just like if you're given 2 points, you can find the equation of the line that goes between those 2 points. Now we're given 3 points. 3 points? 3 points. What is the equation of the parabola that goes through those 3 points? And the 3 points are 0, 0, 1, and 1, 2, and negative 1, 6. And we want to find A, B, and C. We want to find A, B, and C that will give us a parabola that contains these 3 points. If it contains these 3 points, those 3 points have to be solutions for this equation. So let's go ahead and plug these into this equation. Remember, that's the y coordinate. So starting with the top, maybe, I don't know, there's the y, 1. What's x? 0. Well, that makes that nice. So C. So C is 1. So it turned out to be very, very nice right away. Second point, 2 is y. X is 1, so put a 1 in there. We get A plus B plus C. And then coming down here, we'd have 6 equals, put a negative 1 in there. A minus B plus C. We know C is equal to 1, so I can swap out a 1 here, plus 1, plus 1. Let's just look at these two for a second. Let's subtract 1 from both sides and switch sides to write it in a more standard way. So we'd have 1. So I brought the 1 over here, and then I switch sides. And then this one here, we'd have A minus B equals 5. Hey, in the theme of elimination here, let's subtract this row from this row. So we have A plus B equals 1, and this minus that. A's are gone, this minus that, negative 2B. This minus that, 4, so B would have to equal negative 2. And if B equals negative 2, let's come back, I don't know, come back here. A minus 2 equals 1, so A has to equal 3. So, in fact, the equation is y equals 3x squared minus 2x plus 1. And that is the equation of the parabola that contains these 3 points. Hey, I mean, you don't have to check or anything like that. If you wanted to, you could look at something like Desmos, and you could quickly graph this, and then use the trace feature. Just trace along the graph and make sure that these 3 points are on there. That might be a nice thing to do. Didn't have to do it. Okay, I'm going to end this video here, and then we'll keep going on the test with more videos.